with this is as we were merging in our gun, often we were seeing everything in the scene, and that made it really complicated to grab things in particular. So notice that by default our view is set to ghost other objects. It means that it's showing the objects at object level, but this is the only one highlighted, okay? So I almost always set this to hide other objects, because if you're building stuff in Houdini, you're usually focused on the task at hand, and that is object Geo1. I only see what's in object Geo1 if I'm hiding other objects, okay? Another thing is the home. How do you home stuff? So say we're way out here, we don't know what's going on. I'm just gonna hit spacebar H, and that'll kind of center my view, okay? As for the kind of the mousing around and viewing and stuff, that stuff just takes time. To home in on a polygon, you can, oh, that normally works. Spacebar G, okay, there we go. So it's kind of zoomed into that. So, you know, spacebar is your generic way to escape out of whatever operation you're doing, so you can manipulate your view. And then you just have a few useful things like spacebar G or spacebar H just to center your view. So those things you'll get, you know, used to that if you just do more and more stuff in Houdini. You stop thinking about it after a week or so. Okay. So yeah, so we went through, we got that, we got these other things. So now let's take a look at these particles. Okay. So first of all, particles, they have a start time. You cannot in Houdini, you know, scrub through and then go backwards. Why is that? Anyone have a guess as to why that works that way?
This is the way simulations are computed?
Yeah, so they don't really compute from this frame back to here. They only really go forward in time, right? They always grab the previous result and they apply that to the next set of calculations. So SOPs, on the other hand, it pretty much cooks at every frame. I can go forwards and backwards and everything like that, but particles you can't. Particles are only going in one direction in time. All right? Okay. Now, here's the start time. Start time is set to 0. Now, this is in seconds. So right now the start time is 0 seconds, which is frame 1. Okay? Now, if I wanted this to start at frame 55, I would go 55 divided by $FPS, and that's the local variable for the frame rate. Okay, so it's 55 divided by 24. So now my simulation won't start until then. Okay, so these are the parameters on the top of the particle system. I'm just going to set that back to 0. There are handy things like pre-roll time or initial state. For instance, if you had a baked out result from another system and you wanted to apply that to the starting point of this system, you could do that. Oversampling, does anybody know what that is? What is oversampling? Yep.
They calculate several times.
Yes, but several times during what?
Between frames.
Yeah, between frames. Good. Okay, so basically by default, a particle will give you a result after each frame. That's 24 frames a second if you're dealing with film, right? But sometimes you need a little bit more accuracy than that. Like, what if a particle is going super, super fast and it didn't really collide with the wall very well? Okay, maybe it needs a bit more calculations to, you know, get that collision, or maybe it's bending in the air and you really want to have a nice curve, an accurate curve as to where it would collide with the wall. So in that case, you'd increase this. There is a school of thought in effects that says you should never use oversampling, and I pretty much disagree with that. The reason I disagree with that is because maybe you don't need oversampling for the effect at hand usually, but sometimes you need data from that system to apply to another system that needs more accuracy. So there are uses for it. But you shouldn't just automatically say, okay, I'm going to have a better simulation. Let's crank it up to 100. I'll have an awesome sim. Usually you only need one. Okay? See the difference there? Okay. All right. Okay, so source pop. Let's take a look at that. Okay, so by default, you're going to get an error. Okay, it's that these red lines mean something's wrong. What is the error? Oh, it says cannot obtain the geometry. Okay, it's because we don't have any geometry in it yet. Just because you plug something in here doesn't mean that Houdini knows what to do with it. So we either have to say, okay, I actually want to use facet 1. Now it got it. Most people don't do it this way. Most people are lazy, so they just say use the first input. Okay, so that'll say, okay, use whatever's plugged into the first input. All right. Okay. Next is, okay, we have some really, really useful abilities here. I'm going to go ahead and take off this animation for a second. Okay. Okay. So we'll notice that by default, it's actually spawning off of each point in an ordered way. So it's going like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Basically, it's actually doing these points in order, one after the other. If I were to do a grid here, okay. So notice that it's gonna actually be spawning particles. Let me do the facet here so we have normals. So you can put some force on it. Okay. You see how it's going in nicely neat ordered patterns? Okay, now I've dealt with other particle systems that you actually needed special plugins to do like point order, and it might not seem very organic. Like going in neat fashioned order of points maybe isn't the most natural thing if you're talking about stuff, you know, bursting off of other stuff, but often you're not using particles for organic effects. Often you need a very, very controlled thing, and this is a lifesaver. So the fact that Houdini actually pays attention to point orders and point counts and does things in a fashioned way is pretty cool. Now, however, we actually don't want that for this. For this, we could either do like points random, okay, getting a little closer to an effect there, or in this case, surfaces random. So instead of the points, I'm going to birth off the surfaces. Now it's going to be completely random on the surface. Okay. So put this guy back in there. All right, there we go. Okay, now it's just coming completely random fashion out of our gun surface. Okay. Okay. Now that's probably a little bit too many bullets, right? Like, unless we've got a really, really, machine gun in that little pistol there. We don't want quite that many particles. So over on to the next tab, I'm going to go to birth. Okay, so right now we have two modes that we could use. All right, so impulse activation. Impulse activation is set to 1. And what's the impulse birth rate? Well, I'm going to birth 5 particles on every impulse. What that means is every frame every time the particle network cooks, I'm going to get 5 random particles. Okay, so you can see the steps here if I do it like this. Okay, now if I have more sub-steps, then that will mean a thicker stream. Okay, so this guy is dependent on samples. This method right here, impulse. Okay, now the other method, constant, is not dependent on substeps. So right now we're going to birth 10 particles a second if I go to constant. So that doesn't matter if I have 10 substeps or 1 substep. I just want 10 particles a second. See? Same result. Alright. Now, the impulse would be useful if I say something like the current frame equals 48. And I set this to say 1. So what I just did there is my impulse activation is only going to be active on 48. And it's going to birth 1 particle. See? So that's where I would use impulse, is where I needed a very specific timed particle to emit at that frame. Okay. If I just want a constant, emission, which in this case I think I want constant, I'm going to emit like, I don't know, 4 bullets a second. Oop, and my constant activation is 0. That's why. There you go. There we go. So there's 4 bullets a second. Alright. Alright. Now, the next thing is life. So, by default, these particles are going to be alive for 100 seconds. That's a long time for a particle. Okay. Now, since they're bullets, that makes a little bit of sense, though, because a bullet isn't really going to disappear. But let's say I only set it to 1. That means that these particles are going to start disappearing once they get older than a second. All right. And we can see that on the spreadsheet, that we have this thing called life in here. Okay. You look at that life right there. See how that life is counting up to 1, and after they get to 1, they disappear? Okay. The next thing is life variance. So if I were to put 0.5 here, it means that my life expectancy could be anywhere from 0.5 to 1.5. So now it'll be random variance of life. See that? It's easier to see if we have a bit more particles. Let's try this. See how they're disappearing at different times? Okay. There we go. Okay. So that's that. Since they're bullets, I'm going to leave that to, let's say, like 10 seconds there. Okay. No variance. All right. And then, depending on how good of a shot we are, we might want to add some variation. So by default, it's under attributes. We're inheriting the normal of our point, and if we had velocity on the point, we'd also be inheriting the velocity. But what if we wanted to add a little bit of random variation to that? So here, if I say add to inherited velocity, I've got this variance thing down here. So now it's going to go in varied directions from that starting point. Maybe we want less than that. Let's try 0.2 in all the different axes. There we go. Okay. All right. And if we wanted them to go overall more up, I could set this to 1. See, now it's going up a little bit more. Say we don't want to inherit the velocity. We can just say set. Okay. Now it's only using our values we put in there. Okay. I think I'm going to use the inherited velocity because I want it to go straight, but I want it to go a little bit faster. So I'm going to say use inherited velocity of 2. Now it's going a lot faster. Okay, let's try 3. There we go. Okay, and I'll set that back to 4 particles a second. And let's apply that transform again. There we go. All right. So yeah, I mean, just you know, when we go back to our desk, just take some time and really explore all the different things we can do with this source, because it is used quite a bit. Sometimes the only node you need in a particle system is your source. Okay. I'll call this source from bullet. Also notice that we have a different set of tools because we're in particles. Okay, these tools don't exist in SOPs, do they? We don't see all the other things we used to have. We have a much smaller tool set of stuff we can do here, but they all pertain to particles because we're in POPs right now. Okay, so once we get our gun firing stuff, I'm going to add a collision. So for that, where do we think we should, which we don't have many to choose from here. Which one do you think I should use? Yeah, all right. You guys are getting the hang of this. So, by default, it's not going to collide with anything. Why is that? Exactly. So, what do I collide with? I can collide with a SOP that's plugged into my second input. So I'm going to say use second context geometry. Aha. And this is the template flag, so it means we kind of see what's going on here. See, so I don't see it right now, but if I turn it on, it just gives you a little preview of it. There we go. Okay. Okay. Now, the default behavior of a collide is to kill the particle once it hits it. I don't want it to do that. So, right over here, in behavior, instead of die on collision, let's just say bounce on collision. All right. And perhaps I could use a better animation there. All my my gun seems to be going in the other direction here. So not a very good shot, obviously. Okay. There we go. Yep. And it can be challenging to get right to that keyframe. There we go. Okay. A little more aimed at that wall there. Okay. There it goes. All right. I'm going to increase my point count just so you guys can see it a little better. What's happening? Alright, so it's colliding with the wall. It's colliding at the same velocity that it hit the wall at, and it's inheriting the tangent. Okay, so there's two components of a collision. One is how fast, and the other is the angle. Alright, so both are set to 1. It means it's basically like a mirror. It's a perfect deflection. If I set the tangent less, see what happens? Okay, so it's a different angle. It's not inheriting that angle anymore. It's only 10% of the angle. If I do the normal as 10%, as well, now I get much weaker collisions. Okay. All right. Okay, so I think that's our first step. Is really just to adjust the parameters on the source, and get the collision to work. One more thing we can try for there is to play around with the force. So see how it might react to gravity. Anybody know what the force of gravity is in the real world? Oh, come on, guys.
-9.8 meters per second.
Yes. -9, and since Houdini is in meters, our force would be -9.8 if we wanted to simulate gravity. Okay. Not a very powerful bullet. Okay. We can increase our. We could do two things. We could either decrease the gravity, or we could make the velocity stronger. All right. Okay.